Over the last 250 years, the Kosi River has violently dragged its entire channel 150 kilometers across the earth, swallowing whole districts in its path. This map of Bihar shows exactly what that kind of volatility leaves behind. A staggering 73% of the state's total landmass sits squarely in a high-risk flood zone. Every river possesses a distinct geological anatomy and a predictable behavior pattern. This study of a river's physical form is known as morphometry. To understand why a state repeatedly drowns, we have to look past the sheer volume of the monsoon rains. The actual danger is permanently coded into Bihar's hidden geographical architecture. This map illustrates the Ganga River acting as a massive physical axis. Flowing west to east, it cleaves the state directly into two distinct halves, north and south. These two zones have completely different origins. The rivers in the north, like the Gandak and Kosi, are perennial, fed year-round by melting Himalayan glaciers. The southern rivers, like the Son and Punpun, are born in the peninsular plateaus and rely entirely on seasonal monsoons. Because of this, North and South Bihar operate as two completely separate hydrological universes. A flood in the north is driven by entirely different scientific mechanics than a flood in the south. As the northern rivers descend from the Himalayas, they carry millions of tons of mountain silt. When they finally hit the flat plains, they don't flow in a straight line. They snake and curve across the land. This top-down diagram illustrates the velocity vectors of a river curve. Water moves much faster on the outer edge, actively eroding the bank. On the inner edge, water slows down, dropping heavy silt. Over years, the curve becomes so extreme that during a flood, the river takes a shortcut. It pinches off the loop entirely, flowing straight. The abandoned, U-shaped bodies of water left behind are called oxbow lakes, or chowers. The landscape of North Bihar is littered with them, proving that the river's natural state is to constantly cut, shift, and completely redesign the plains. If a river naturally shifts its path, the human response is to build massive concrete walls to lock it in place. We build embankments. This cross-section diagram reveals the fatal flaw in that engineering. Before the walls, floodwaters would spread the mountain silt across miles of plains. Trapped between concrete, heavy silt sinks straight to the riverbed. After decades of this trapped silt building up, the floor of the Kosi River has been raised several feet into the air. The river now flows physically higher than the elevation of the surrounding villages. When the pressure finally fractures the concrete, the water doesn't gradually rise, it drops like a waterfall from above. And because the riverbed is now elevated in the sky, the water in the villages has absolutely no gravitational path to flow back in. By attempting to put a straitjacket on the rivers, engineers permanently trapped the water. This design failure has subjected 16% of North Bihar to permanent waterlogging, turning seasonal rains into inescapable tsunami-like events. The Kosi River's violence is an inescapable function of its basin's physical geometry. This side-by-side comparison shows two distinct basin shapes. In a long, rectangular basin, rainfall from different areas arrives at the main channel staggered over time. But the Kosi has a nearly perfectly circular basin. Raindrops from all outer edges traveled the exact same distance, converging at the center simultaneously. This is a bifurcation ratio. Imagine a crowded stadium where everyone tries to leave through a single narrow exit door at the exact same time. Thousands of tiny mountain streams dump their water into a tiny exit channel, creating a violent bottleneck. This flash flood effect is a mathematical certainty. The physical shape of the mountains guarantees that the Kosi will always surge with extreme sudden violence. Down in South Bihar, the rivers don't come from the Himalayas. Rain-fed rivers like the Punpun flow north, attempting to empty their waters into the massive Ganga. But during the heavy monsoon season, the Ganga's water level is incredibly high and flowing at maximum velocity. It acts as an impenetrable liquid wall, outright refusing to let the smaller southern rivers merge into it. This rejection causes the backwater effect. The southern rivers hit the Ganga and are forced to flow backward. The trapped water spills over miles of flatlands, creating massive, temporary shallow lakes known locally as Tal. South Bihar drowns. But it doesn't drown because its own rivers are aggressively overflowing. It drowns because the immense pressure of the Ganga traps their water and gives it nowhere else to go. Yet this intense hydrology has a dual nature. The exact same floodwaters that submerge the state in the summer become its ultimate life support system in the winter. When the massive southern tall lakes finally dry up after the monsoon, they leave behind thick layers of pristine, highly fertile silt. Areas like the Mokomatal are transformed into a highly lucrative agricultural grain bowl, perfectly primed for winter crops like pulses and oilseeds. Beyond the agricultural plains, this drainage system has sculpted massive vertical features, like the 47-meter drop at Kakalot and the deep limestone ravines of Kaimur. Bihar's geography operates on a relentless cycle of destruction and creation. The violent summer floods are the exact mechanism that delivers the region's extreme agricultural wealth and ecological diversity. At the historic Brahmakund in Rajgir, boiling water erupts directly from the ground, a geothermal anomaly in a state defined by flat river plains. Rainwater seeps deep into underground fault lines beneath the Rajgir hills. It drops far enough to hit the Earth's internal heat, the geothermal gradient. The water boils to nearly 150 degrees Celsius and shoots back to the surface under extreme pressure, absorbing heavy medicinal minerals along the way. The wildly shifting Kosi, the severed oxbow lakes, the backward-flowing tall zones, and the boiling geothermal springs are not isolated events. They operate like two different blood circulation systems pumping within a single living body. The catastrophic failures in Bihar happened because we believed we could force a living geological entity into a concrete straitjacket. Prosperity here requires accepting that water will always find its path, and our best chance is learning the science of flowing alongside it.